Okay, so this lesson is about the idea of absolute and percentage error. We finished off last lesson rounding numbers. So when you round off, are you keeping all of the information anymore? You're cutting it off, so it's not exact anymore. Okay? So when you're rounding, you're approximating a real number. It's like you're sort of just getting around or close to it. It is important to acknowledge this inaccuracy, which is called error. If you have a mistake, you made an error. If you're inaccurate, there's an error somewhere. The basic size of the error is known as the absolute error. So your formula for absolute error equals this vertical line, VA minus VE, and another vertical line. What does VA stand for? It's the approximate value. It's the guess. VE is the exact value. It's what it really is. And what do the vertical lines mean? It means we ignore if it's a negative number in there. Because is it possible to guess too big? Like if I was to guess my height, is it possible to say, oh, I reckon Mr. T's like 2 meters tall, which I clearly am not. So that's an overestimate, right? Is it possible to guess under? Is it possible to say, yeah, he's a short king, he's like a meter tall? Right? But do you agree that if you told me that I was a meter tall, wouldn't this come out as a negative? Because your guess is a meter, my exact height is like 168 centimeters, so you'd get a negative number. But with absolute error, all we care about, well, is how wrong you were. You would be out by 68, okay? So I'll give you a couple of moments. Can you get the explanation for absolute error? And then I'll detail that a bit more. So the vital stuff in blue, the black is just to help me explain it. So again, the absolute error is your guess, the approximate, minus what it really is, and then ignore if the answer is negative and positive. You're just how wrong are you? Because we ignore the negative, the absolute error is just telling us how many units the guess was out by. How wrong was I? Sometimes that's not that useful depending on the scale of numbers we're talking about. So what does that mean? If my absolute error, if I was wrong by 15 centimeters, do you agree that a mistake of 15 centimeters is quite big if my thing is 30 centimeters? Because 15 centimeters is that wrong, okay? That's quite a lot. That's half of this. That's pretty wrong. Whereas, see the top of the whiteboard here, the whole rectangle one, that's about 3 meters. You see up the top there? Is 15 centimeters a really bad mistake in that situation? Yeah. See, so do you agree that if I said, oh, I was wrong, I was out by 15 centimeters, you want to know more information? Because 15 centimeters is pretty wrong if you're talking about, I don't know, the size of a, I know, an Easter bunny, chocolate, but it's not that bad if we're talking about the size of a room, okay? So that's where percentage error comes in. Why? Because everyone has a pretty good understanding of percentage error. So I'll give you a couple of moments. Can you get this formula down? And then I'll detail why percentage error is better. So percentage error is equal to, in brackets, the absolute error, what we just got before, divided by the exact number and times by 100%. So a couple of minutes to get that formula, and then we'll talk about why that's slightly better than talking about absolute. So why is percentage error most useful? Percentage error is always useful. Because if I said I was 2% wrong, is that really bad? No, it's not that bad. What's 2%? What's 2% of 30 centimeters? 0.6 centimeters. So a 2% error of this ruler is like that. Is that bad? What's 2% of 300 centimeters? 3 meters. 0.02 times by 300. 2% is 6 centimeters. So 6 centimeters for that whole board, it's not that bad. But if I said, oh, Mr. T, I was wrong by 50%, is that pretty bad? What's an example of 50%? Let's say you got pulled over by the cops in an 80 zone. A 50% error means you're driving at 120. Is that bad? Yes. See how this can be tricked, whereas percent cannot be tricked. Right? So it is bad. So, let's see. Let's do a little test. This will be recorded, just take a second. Mr. T's 11 general math class, on average, guessed his age to be. How old do you think I am? 30. You?
34.
How do I find the average of something? Add everything together and divide by. So 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Divide by 15. So on average, this class thinks I'm 31.2 years old. I'm 38. Find the absolute error. So how do I find the absolute error of something? What was the approximate? What was the guess here? It was one of these two numbers. Which was the guess? Good. So absolute error equals line approximate 31.2 minus 38, which is the exact. 31.2 minus 38 is negative 6.8, but what do the lines tell you? I ignore the negative, so it's just 6.8 year error. Okay? That's pretty chunky for, we're talking about 38 years old, but if I was 100, is 6.8 years, that's not as much, okay? So then let's find the percentage error. Percent error equals the absolute error. Did I just find the absolute error? 6.8 over, what was my exact value of it? Yeah. Work that out first in the brackets. Times it by 100 and then put a percent sign on the end of your answer. So 6.8 divided by 38, times that by 100. So your percentage error was 17.89% to 2 decimal points. That's how percentage error works. So that's not a huge error, but do you agree it's a little significant? It's a chunk. Okay? That's nothing bad. Can you get that example, Jonathan? And that's the end of the first video.